अच्छा, so we're going to try and do MCQs now. ठीक है. So अच्छा, so the concept of bond energy, bond length, and bond polarity are useful when comparing the behavior of similar molecules, thermal stability. For example, it could be said that HCl molecule, the bond is dash of the HI molecule. The bond length, okay, the bond is. So which one is the correct option? Okay, so he's talking about पहला वाला कर लेते हैं. The bond energy. Okay, what's wrong with that? The bond energy is greater. So is that true if HCl of the bond, sorry, the bond energy, तो समझ नहीं आ रहा. अच्छा, so bond energy is of the HI molecule is greater. Is that true? किसका bond ज़्यादा strong है? HCl or HI? Smaller atoms, do they make strong bonds, or bigger atoms make strong bonds?
Smaller atoms.
ठीक है, smaller atoms make stronger bonds. So ये greater होगा ना? So this is wrong. Okay, compared to HI's bond energy is going to be lesser. It's not going to be greater. So ये वाला part गलत है. ठीक है, so अच्छा, तो एक तो ये. The next one, bond length is greater. So bond length is smaller atoms obviously have smaller bonds, and bigger atoms have bigger bonds. So HI की जो bond length होगी, that's going to be greater, right? So that one, number 2, is perfectly right. Is that clear? HCl is going to be small, and HI is going to be much bigger in size because it's got bigger atoms. Okay, is that clear?
Yes, sir.
अच्छा, फिर the next part is polarity भी है. That's polarity. So which one is going to be more polar, HCl or HI?
HCl.
HCl is going to be more polar, right? Because Cl is more electronegative, so it's going to be it's more electronegative, so it's going to be more polar as well. So in that sense, this one is also true. HI is going to be less polar. So the third statement is also true. So in all cases, the HI bond length is going to be greater. The HI polarity is going to be lesser. But the first one is wrong. The HI bond energy is not going to be greater. It's also going to be lesser. Is that clear? Are you clear?
Yes.
Yes, sir.
Achha, so the next one is, which sodium salts form a precipitate when silver nitrate followed by dilute NH3 is added to its solution? So that is about the test of halide ions, and the test for that is, okay, Cl-1 forms a white precipitate, Br-1 cream precipitate, I-1 forms a yellow precipitate, but Cl-1 precipitate dissolves in NH3, but Br-1 only dissolves in concentrated NH3. So, and the I-1 is not soluble at all. So the only one that's going to form precipitates are going to be in dilute NH3, not concentrate. So it's going to be Br-1 and I-1. Cl-1 is not going to form precipitates. ठीक है? और बल्कि मुझे यहाँ पे ना वो खोलना चाहिए, the hydro board, 1 second, जहाँ पे.
So, sir, chlorine doesn't form any precipitate.
No, it does. Wait a second.
But not with NH3.
It does, but with NH3 the precipitate dissolves. ठीक है?
Okay.
मतलब इसके अंदर वो extra points था ना कि वो मैंने equation भी लिखी थी कि the equation was anyways group 17. So this one. So I told you that that with AgCl precipitate is formed, but with NH3 it dissolves. I mean, this is the part where it's dissolving. The others, the last one will not dissolve. The Br-1 precipitate will dissolve, but only in concentrated NH3. So moving to the next one, you've got the next one is the element lies below iodine. What will be the property? So it forms diatomic molecules there, which dissociate more readily. So will they break bonds more readily or not? They do form diatomic molecules, right? So, and it's at the bottom of group 7. So kya hoga? Is it easier to break bonds compared to chlorine or difficult?
I think easier.
Easier because bigger bonds, like smaller bonds, are harder to break. Astatine is going to be diatomic, but it's going to be a bigger atom. So the bond length is going to be very large. The shielding of electrons, there would be a lot of shielding. The electrons would be very far from the nucleus. So it would be very easy to break those bonds. And the trend that you see over here is, I mean, it's given over here as well. HF, it's very strong. HI is very weak. HI is so weak that it doesn't even form. If you try to form HI, it instead forms an equilibrium. It breaks down again and forms H2 and I2 back again. So it's pretty hard to, it's very unstable. It's very hard to actually even form HI in the first place because it decomposes very easily. And there are a lot of Haji.
One question about the test of halide ion. For Cl minus, it dissolves in both dilute and concentrated.
I mean, it's obviously going to dissolve in concentrated as well.
Oh, okay.
Because if it's if it's obviously dissolving in dilute, then it's definitely going to dissolve in concentrated.
Okay. And for Br1 minus, it's only concentrated.
Yeah.
Okay.
Just remember this as well, that HI would even decompose, it would break down if with a hot glass rod. Like if you...
So when we're done with the lesson, can you also send this board as a PDF?
Yeah, I can't make a PDF out of this. I mean, you can make a PDF out of this, but it's going to be a very big PDF. So
okay, can you just send the board link?
I'll send it. I'll send it.
Okay.
So the next question, we've got ammonia and chlorine react in the gas phase. Which statements about the behavior is correct? So ammonia behaves as a reducing agent. So a reducing agent, what happens to it? It gets oxidized, right? So it's going to get oxidized. So is it getting oxidized? What's the oxidation state of N over here? I mean, it's
-3.
T gets -3. And N over here is 0. So it is definitely getting oxidized. The oxidation state is increasing. If it becomes if it increases, that's oxidation. Then the next one is ammonia behaves as a base. What does a base do? A base accepts H+1 ions. So is it doing that? You've got NH3, and over here you've got NH4+1. So you've got NH3, and over here this one you've got NH4+1. So it is definitely accepting H+1 ions as well. So it is behaving, I mean, both the first two statements are correct. The oxidation number of the hydrogen does not change. That is also correct because H is +1 and H is +1 over here as well. So all three statements are correct. Is that clear?
Yes.
Yeah, sure.
So chlorine compound shows oxidation states ranging from -1 to +7. So the question is, what are the reagents and conditions necessary for the oxidation of elemental chlorine into a compound containing chlorine in the +5 oxidation state? So when is basically asking, when does it form a +5 oxidation state? So you must remember these two reactions, specifically this disproportionation reaction. That chlorine in cold NaOH, it forms NaClO where it is +1, but in hot NaOH, temperature greater than 70, it will form NaClO3 where it is +5. So you must remember, memorize those two reactions of chlorine. So this one is the correct answer. TK is just part of, I mean, you just have to memorize this. Now, which gaseous hydride most readily decomposes into its elements on contact with the hot? We just did that. I just told you that HI, the bond would be very weak. Is that clear?
Yes.
So why is the addition of concentrated sulfuric acid to solid potassium iodide unsuitable for the preparation of hydrogen iodide? And the answer to that is it's this part. Okay, what did we learn? That down the group, if you have a halide ion, it becomes really easy to lose electrons. Fluorine and chlorine are very electronegative. So if they gain they like to gain electrons. They don't like to lose electrons. But Br and I, if they gain electrons, they would also lose electrons very easily. The I-1 would quickly lose electrons to form I2. So it's a very good reducing agent because it gets oxidized very, very quickly. Bigger ions, they're more shielded, they lose electrons very easily. So we did this, that when you react them with concentrated, so when you react them, with concentrated H2SO4, Cl-1 does not like to lose electrons. So which is why it doesn't like to lose electrons. So the only reaction that happens is a displacement reaction where if you mix NaCl with concentrated H2SO4, there is no redox reaction. No one gains electrons, no one loses electrons. The only thing that happens is that if the sulfuric acid is very concentrated, the H+ ions will combine with the Cl ions and they would form HCl gas that would form white fumes of HCl, and they leave the solution. And what's left is sodium sulfate or NaHSO4. But when you go down the group Br-1 and I-1, they do have displacement, but I-1 really likes to lose electrons. So I-1 quickly turns into I2. And sulfur is then supposed to gain electrons, and it will get reduced. So the question is, why is the addition of sulfuric acid to potassium iodide unsuitable for making HI? Because the HI would eventually lose electrons and it will turn into I2. So iodide ions are oxidized to iodine. That's true. Hydrogen iodide is not displaced by sulfuric acid. It is actually displaced by sulfuric acid. They compare. So it is actually displaced, but the problem is that it ends up getting oxidized during the process. So the product is contaminated by sulfur compounds. It is contaminated by sulfur compounds, and that is also true. That a lot of sulfur compounds are produced. Sulfur itself is produced. So that one is also true. So that is a valid reason as well that it's an unsuitable way of making. It's an unsuitable way of making HI. You clear?
Yes.
Yes.
So in what order does the reducing power of the hydrogen iodide halides increase? So it's this one. They increase. I-1 loses electrons very easily. Cl-1 doesn't like to lose electrons. Which statement is most likely to be true for astatine, which is below? So it's right at the bottom of the group. So astatine and potassium chloride react to form. So displacement. This is about displacement. So displacement is a more reactive halogen displaces a less reactive halogen. So who's the most reactive? The top one. Who's the least reactive? It's the bottom one, iodine. So fluorine, most reactive halogen, displaces a less reactive halogen from its compounds. So Cl2 really likes to gain electrons, so I-1 would be the one that would lose electrons. So it's going to be a redox. It's going to be a redox reaction. Cl2 Cl2 likes to gain electrons, and I-1 ends up So that ends up losing electrons. But anyway, so acetylene and potassium chloride react to form. They're not going to react because it's not going to be able to displace chlorine. Potassium acetaldehyde and hot dilute sulfuric acid react to form white fumes of only. This is also not true, because right at the bottom, it would be a very good reducing agent. So right at the bottom, potassium acetaldehyde is going to be a very powerful reducing agent. So there's not just going to be displacement, there's going to be a lot of redox reaction as well. In the case of Br-1 and I-1. So that is also not true. You don't know, clear? Is that clear?
Yes, sir.
Yes.
अच्छा, फिर है कि silver acetate reacts with ammonia to excess to form a soluble. I mean, they're not going to form. If you follow the trend, it's not going to form a soluble complex. If you look at the precipitate, I-1 down the group, the precipitate becomes more insoluble. The first one dissolves, the second one dissolves barely, the third one does not dissolve. So the one at the bottom, that's definitely not going to dissolve. So it's not going to form a soluble complex. That's not going to happen. And sodium, and that is true. The last one is true. Okay, it's going to be a very powerful reducing agent. And it would lose electrons very easily because it's so big in size that it would lose electrons very easily, and it would form, it will get reduced to the element back again. Achha, the next one is when this is again about when a hot glass rod is placed in a just hold on 1 minute. As the next one, a hot glass rod is placed in a gas cell of hydrogen iodide. There's an immediate reaction as hydrogen iodide decomposes. So, which statement of the reaction hydrogen iodide is purple colored? No, it's not purple colored. Iodine is the one that's purple colored. The hot glass rod provides the activation energy. That is true because some amount of energy is needed to break the HI bond, although it's very weak. But that energy is going to come from the hot glass rod. So that is your activation energy. One of the products is a solid. Iodine that is formed is definitely going to be a solid. So 2 and 3 are correct. Can you be clear?
So which of the products is solid?
Iodine. Like iodine over here. Yes, state with the iodine is a blue-black solid, right? The other product, when the HI decomposes, the other product is hydrogen, which is obviously a gas.
Got it.
अच्छा, फिर है कि अच्छा, ये क्या था? अच्छा, फिर है कि you've got this one. Drums of bromine broke open after a vehicle crash on the motorway. Traffic was diverted as purple gaseous bromine drifted over the road. It is denser than air. Causes irritation to driver's eyes. Firemen sprayed water over the scene of the incident, dissolving the bromine and washing it away. What is wrong with this report? Bromine, I mean, this is what is 100% wrong. It's less dense than air. How do you figure out bromine is more dense than air? Because if you look at Br2 has a mass of 160. Do you know what the average molecular mass of air is? What's the MR of air? वो मुझे बता दो कितना है?
28, 29.
ठीक है, it's around 29 because it's air is mostly what? It's two molecules, oxygen and nitrogen. So one of them is 28, the other one is 32. And there's 78% this and 21% this. So if you take out the average, it would come out to be around somewhere around 29. So it's obviously very, very heavy. And remember, all gaseous molecules, they occupy the same volume. So if you calculate density, if you calculate density as mass over volume, then obviously it's going to come out to be the volume is constant for all gases. The volume is the same. So that is definitely true. Bromine does not dissolve in water. It does actually kind of slightly dissolve in water. Not very readily, but some of it might dissolve. Now, bromine does not vaporize readily. It vaporizes very quickly. Bromine is a very volatile. It's a very volatile liquid. Although it's a liquid, but it's a volatile liquid. Now, which properties in the sequence? As this question is, there's actually one problem. It's not purple. That's it's reddish brown. I mean, this is what bromine looks like. So bromine chemical, one second. So this is what bromine actually looks like. So the thing is, this color can be described as reddish brown. Sometimes it's described as purple as well. I mean, usually it's described as reddish brown, but I mean, this thing. Here's sometimes they even in the papers they would usually it's reddish brown. It's even they often use the word orange as well for that. And very rarely, I mean, this is probably the only question, but very rarely bromine is also described as purple. When obviously iodine is definitely purple. Iodine is like pure purple. I mean, not in the solid form. In the solid form, iodine is a blue-black solid. But when it is a vapor, when it is a vapor, it's a very pure purple vapor. Something like this. So remember, there is sometimes a lot of flexibility shown with describing colors. So bromine, remember, bromine is the confusing one. Orange is used, red brown is used, reddish is used, brownish is used, and very rarely, sometimes they often use purple as well. Now, which property in the sequence steadily increase? Thermal stability decreases. HI is very unstable, right? So what happens to the bond length? The bond length increases. HI is going to have the biggest bond. And the ease of oxidation, do they lose electrons? I-1 loses electrons very easily. So that also increases. Down the group, it becomes easier for them to lose electrons. Can you be clear?
Yes.
Yes, sir.
This one. Now this is about boiling points. Remember, boiling points have nothing to do with the bond. Actually, it's all about intermolecular forces. So if you have two HF molecules, they're going to attract each other, and by the looks of things, they have a very high boiling point. So that means they attract each other very strongly. So what is the intermolecular force that exists between them?
Hydrogen bonding.
So that is hydrogen bonding, right? And this is also described over here as well. Okay, ये वाला part. Okay. This graph over here. Remember, HF is out of the question. That has hydrogen bonds. They're very strong. But what about the rest? The HCl, HPl, and HI. What happens is they don't have hydrogen bonds. So therefore, their boiling points are much lower. But the first one has stronger permanent dipoles. But it's a smaller molecule, so it's got less van der Waals forces. The HI molecule is a weaker permanent dipole. Its electronegativity is lesser. The difference is less. So it's a very weak permanent dipole, but it's a much bigger molecule, so it's got a lot of van der Waals forces. So the reason they're going to ask you about the reason why the boiling points over here they increase, and the reason for that is that even though the permanent dipole strength is decreasing, but because this is a bigger molecule, it's got a lot more van der Waals forces. So remember how the variation in boiling points would happen. So what explains the higher boiling point? Bond energy is not an explanation. You're not breaking the bond when you're boiling something. When you boil water, you don't break the bonds of water. You're breaking the attraction that exists between water molecules. So the effect of nuclear shielding is much reduced in fluorine, which polarizes the HF molecule. That is actually true, because the HF molecule is highly polar. Why? Because fluorine is very electronegative. Why is fluorine so electronegative? Because fluorine's shielding, like if you look at an HF molecule, then the fluorine nucleus is not shielded that much. Fluorine is a very small atom, so the electrons are very strongly it's a very polar molecule. It's one side is negative, the other side is positive, and one of the reasons for that is that the shielding is very reduced. ये बात समझ आई? Is this clear?
Yes, sir.
But so C can also be true. I mean, what's the effect of nuclear shielding is much reduced in fluorine, which polarizes the HF molecule. The effect of, I mean, that makes sense. The electronegativity of fluorine is much higher. That is true in the group. Then D is the proper answer, because the question is, I mean, basically these two statements are also kind of true, but I think the proper explanation is what explains the higher boiling point, which is much higher. That is, they've got hydrogen bonds. Okay, that is that covers all of the other points. Is that clear?
Yes.
So the next one is the graph correctly describes a trend in the halogen group. What is that trend? Bond energy, it decreases. HI becomes, it's a lot easier to break HI. Boiling points, they increase. More van der Waals. Bigger molecules, they have more van der Waals forces. Strength of B is the correct option. Iodine, the reason iodine is a solid is because it's got lots of van der Waals forces. It's a bigger molecule. So B is the correct option. But what happens when chlorine is bubbled through? Chlorine is more reactive, right? It's bubbled through potassium iodide. So more reactive displaces the less reactive. So I-1 are going to get oxidized to iodine. I-1 is getting oxidized. It goes to 0. Chlorine is oxidized to chloride ions. That's not true. Chlorine is reduced to chloride ions. Chlorine is 0. Its oxidation state is decreasing. It's reducing. So the first one is incorrect. Which of the following is not a correct statement about iodine? A crystal of iodine contains covalent bonds and van der Waals forces. Is not correct. That is true. Okay, if you have an iodine molecule, then it will have covalent bonds and it will have van der Waals forces, right? So it will have covalent bonds within the molecule and it will have van der Waals forces between the molecules. TK, clear the first one?
Yes.
The iodine vapor is purple. That is also true. So the first two statements are true. The first ionization energy of iodine is less than that of bromine. That is also true. It's very easy to remove electrons from iodine because it's a bigger atom. It's more shielded. So that is also true. So आखिरी रह गया कि hydrogen hydride of iodine, hydrogen iodide is of greater, it's lesser thermal stability. It decomposes very easily. So not can the D. There is a mixing of aqueous silver nitrate and sodium produces a precipitate, of which the precipitate dissolves, right? Cl-1 precipitate dissolves when you add ammonia to it. So we can color solution kab banega when you add ammonia to it. Okay, is that clear as well?
Yes.
Here, the next one is, what is the complete list of all the products from the reaction of sulfuric acid with potassium bromide? तो पूरी list यहाँ पे कि it's first going to be a displacement, but followed by HBr, and then the Br-1 will also get oxidized to Br2, and sulfur will get reduced to SO2. So what is the complete list of products? Potassium hydrogen sulfate is वो तो वैसे ही correct हो गया कि by looking at the option, obviously it's going to be formed. HBr is also going to be formed. And sulfur is going to get reduced. So sulfur dioxide and bromine, they're also going to be formed. So D is the correct option. You're going to get a lot of products. ठीक है, ये भी clear है?
Yes.
Or so we can try some. So see, the element acetylene lies forms the proper. What will be the properties of acetylene? Yeah, I say it is acetylene, right? It's at the bottom. It forms diatomic molecules more readily than chlorine. That is wrong. It does not react explosively with hydrogen because it's less reactive. Down the group, the reactivity decreases. So it forms which dissociate more readily. First one is correct, actually.
Yes, the first one is correct.
Yeah, it's correct.
The last one, it is a good reducing agent. That is, a reducing agent gets oxidized. So acetylene is not going to, remember the element is actually the oxidizing agent because the element gains electrons. If he was talking about the acidide ions, they are reducing agents. The difference the element, if you're describing the element is always described as an oxidizing agent because it gains electrons. And the ion is described always as a reducing agent. So if he's talking about the element, acetylene is obviously an element because if it had been the ion, it would be called an astatide ion. So an element is always described as the oxidizing agent, not as the reducing agent. Okay? Ye baat clear? Make sure you remember this, that.
Yes, sir.
That the
Yes.
term, make sure you remember
So,
this.
sir, basically in group 17,
Mhm.
chlorine reacts like chlorine readily dissociates, and then down the group it just what do we say, decreases, right? Like iodine likes to really lose.
About electrons, you're talking about electrons, right?
Yeah.
So in group 2, what happens is that the ion, the bottom one likes to really lose electrons, right? When you're talking about the ion.
Okay.
So the bottom one, the reducing power increases. They become stronger reducing agents down the group. But
All right.
if you're talking about the elements have to gain electrons, right? So if you're talking about the elements, you're going to describe them as the oxidizing agent because they're getting reduced. So the top one is the best oxidizing agent because fluorine is very electronegative. It really likes to gain electrons, right?
Yes,
Yes.
sir. All right.
So the ions are described as reducing agents, and the bottom one is the strongest reducing agent. The elements are described as oxidizing agents, and the top one is the best oxidizing agent. So what is the gaseous nitrogen is less reactive than gaseous fluorine, but nitrogen got triple bond hota, that's very strong. So I think it's this one. So what is the addition of sulfuric acid to potassium iodide unsuitable for the, we did that. Property Q of chlorine is smaller than for iodine. What is property Q? The oxidizing ability of the element. Remember, top wala jo hai na, top wala, ye bhi kya tha? That is the strongest. The top one is the strongest oxidizing agent, right? So chlorine is going to be a much stronger oxidizing agent compared to iodine. So it's not going to be smaller, it's going to be much stronger. So this one is wrong. Solubility of halide in NH3. So chlorine is going to be a chloride, halide, chloride is going to be a lot soluble compared to iodide. So this one is also wrong. क्यों उसने कहा smaller होना चाहिए. Strength of van der Waals forces. Chlorine is smaller, so smaller molecule has less van der Waals forces compared to iodine. So this one is true. ठीक है, ये भी clear है?
Yes, sir.
A thermal stability of the halide. This is going to be stable. It's greater stability, and this is less stable. अच्छा, फिर वो कह रहे हैं कि he's talking about. अच्छा, this is also important that he's talking about the same thing, that chloride ions are added. So, sorry, sulfuric acid is added. Iodide, remember, likes to lose electrons, right?
Yes.
So purple vapor is
Yes, sir.
formed. Purple vapor is formed, right? Cl-1 does not like to do that. So it just turns into, it's just a displacement reaction. It combines with the H+1 to form HCl gas. So nothing happens in this case. But when it comes to phosphoric acid, let me explain this part. ठीक है, ये वाला part. इधर कहीं लिखा हुआ भी होगा. अच्छा, now remember this. If you want I-1 to lose electrons, right? I mean, we've been talking about I-1 losing electrons. Remember this, ke an element or an ion or whatever, if I-1 wants to lose electrons, it can't lose electrons alone. There has to be someone who's gaining electrons, right? So if I say sodium really likes to lose electrons, sodium can't do that alone, right? It has to be, there should be some other thing. There's always a reducing agent which is next to an oxidizing agent. Redox happens. I mean, you use the term redox. If there is reduction, then there is oxidation as well. If I-1 loses electrons, then the other one gains electrons, right? So ये बात समझ आ रही है कि you need two things for a reaction to happen. Is that clear?
Yes, sir.
So the reason I-1 is able to lose electrons is because sulfur is able to gain electrons. Sulfur is a good oxidizing agent, which is why I-1 acts as a reducing agent. अकेले ये काम नहीं हो सकता. अगर सल्फर आगे से इनकार कर दे कि I'm not going to gain electrons, I-1 will not be able to lose electrons. Is that clear? So I-1 के electron lose करने में ना कमाल सल्फर का भी है कि it is the one that's also gaining electrons, right? So if I want to stop this redox reaction, if I just want displacement, what should I do? I should stop using H2SO4. Instead of H2SO4, पता नहीं यहाँ पे लिखा हुआ है कि नहीं लिखा हुआ. हाँ. Instead of H2SO4, I mean, use H3PO4 instead of H2SO4. Is that idea clear?
Yes.
Instead of because H2SO4 likes to gain electrons, which is why I-1 ends up losing electrons. If you replace H2SO4 with some other thing, H3PO4, then you'll only get displacement. HBr form hoga, but the Br-1 will not be able to lose electrons. क्योंकि वो आगे से gain ही नहीं कर रहा, तो वो lose किस करे? ठीक है? तो यहाँ पे ना इस question के अंदर ये कि what reduction? Phosphoric acid के साथ ना there's no redox. ठीक है, उधर कोई redox नहीं हो रहा, कोई iodine form नहीं हो रहा, no redox, right? So
Yes.
that means sulfuric acid is a stronger. एक तो ये पहले दो गलत हो गए. Phosphoric acid must be a weaker oxidizing agent, right? Compared to sulfuric acid. Is that clear?
Yes.
और फिर रह गया कि the last one is the correct one. कि दोनों के लिए ना, if I-1 is acting as the reducing agent, right? Then sulfuric acid is acting as a oxidizing agent, right? Is that clear?
Yes. So, sir, for phosphoric acid, no halide ion can further
Yeah.
oxidize.
हाँ,
Okay.
so मैंने वो यहाँ तक ही होगा, फिर reaction ना इधर कि HI form होगा and that's it. Because I-1 will not be able to lose electrons because even though it wants to lose electrons, but there's no one gaining those electrons. ठीक है?
Got it. Yes.
So could you re-explain that question, please?
नहीं, वो मैं कह रहा था कि हम ये कह रहे थे ना कि I-1 really likes to lose electrons, right? So what that meant
Yeah.
was कि once displacement happens, I-1 then starts to lose electrons to form iodine. But I-1 can only lose electrons if there is someone gaining electrons, right? तो अगर
Yes, sir.
ये नहीं होगा ना, तो it will not be able to lose electrons. It will not be able to form iodine. You need someone to gain electrons. ठीक है? तो
All right.
तो इसका मतलब है कि the redox reactions will only happen with sulfuric acid. Because if you replace sulfuric acid with if you replace sulfuric acid with phosphoric acid, the redox will stop. फिर reaction ना यहीं तक होगा, HI तक. Because I-1 will not be able to lose electrons because the phosphoric acid on the other side is not willing to gain electrons. ठीक है? And no iodine will be formed. Is that clear?
Yes.
So basically H2SO4, sorry, without H2SO4, NaI cannot lose electrons.
हाँ, क्योंकि ताली दो हाथ से बचती है ना. I-1 wants to lose electrons, right? So
Yeah.
तो दूसरे को gain करना पड़ेगा ना. But if the other one is unwilling to accept those electrons, then it won't be able to lose electrons, right? So if you replace sulfuric acid by phosphoric acid, इधर मैं वो add भी कर देता हूँ कि well, it's phosphoric acid is a good oxidizing agent or acts as one. तो इसलिए वो I-1 is able to behave as a reducing agent with sulfuric acid, but not with phosphoric acid. ठीक है? बल्कि
All right, sir.
इसमें और मैं ऐड कर दूं कि फिर वो जो अगला वाला पार्ट था ना कि Br-1 and phosphoric acid, उसके आगे फिर होगा कि no reaction, no redox. ठीक है?
Yes.
Yes, sir.
चलें ठीक है. कल कंटिन्यू करते हैं. ये हमने वैसे कर ही लिया.
All right.
चले. ओके.
Okay.
हाफिज.
Allah Hafiz.